Hey everybody. Today we're going to be talking about solving systems of equations using any method. And so you will have your options whether you want to use substitution method, whether you want to use the elimination method, whatever method you would like to use for each problem, you can decide. Certain methods are better for certain problems than others. And so you can see on the screen here we have three different problems. And could you, by looking at these, be able to determine what would be the best method to use? Number one, for example, I can see here that I have two equations that are both written in standard form. And so it wouldn't be too hard to use the elimination method here. You know, I could either eliminate the y's if I were to take this second equation, multiply everything by -2. Or I could eliminate the x's if I multiplied everything in the top equation by -3. Number two, though, it looks like substitution might be the better method on this one because the first equation already is set equal to y equals 2x minus 1. So I could substitute 2x minus 1 in for y in this second equation. And back to this third problem, or onto this third problem now, I'm looking at my n's, and it looks like if I multiplied my top equation, multiplied everything by -2, I could get that set up well to eliminate the n's, solve for m, and then go from there. So anyway, let's look at number one, and let's talk about how I can use elimination here. What I can do is if I take this second equation here, I got to get myself pen here. Let's see here. It's been a while since I've done this. I haven't made a video since last year. Here we go. If I wanted to, I could take everything in this second equation here and multiply by 2. Now, actually, some of you might be thinking maybe it would be better to multiply by -2, and I think I did mention that earlier too, that multiplying by -2 would be the best move here. So let's just multiply by 2 and you'll see why multiplying by -2 would have been helpful. My top equation, x minus 2y equals 9, I'm going to write that down here, but I'm going to show the 1 in front of the x. 1x minus 2y equals 9. And in the second equation, if I multiply everything by 2, all of these terms here, 2 times 3x is 6x. I have minus 2 times 1y, there is a 1 in front of that y, even though it isn't shown, we know it's there. 2 times 1y gives us 2y. And that equals 2 times 7, which is 14. All right, now you'll notice here, these two terms are the same. If they were opposites, they would cancel right out. And so you could go ahead and multiply everything in this bottom equation by -1 now. Make this -6, make this plus 2y, make this -14. And now these are opposites, they will drop out. Okay, now if I had multiplied up here by -2 from the start, -2 times 3x would be -6x. -2 times, here we have plus -1y. -2 times -1y would be positive 2y. And -2 times 7 gives us the -14. We'd get there in one step. All right, anyway, we can add these now. 1x plus -6x is -5x. These terms cancel out. They're opposites. Minus 2y plus 2y. Those are inverse operations. And so what does this equal? 9 plus -14, which is -5. Then I just have to divide by -5 here, divide by -5 here. This cancels out, and I get x equals positive 1. Once we know what x equals, we can substitute that back into either one of these original equations and solve for y. I'm going to use the top equation here. I think it's a little bit nicer than the bottom one. We have x minus 2y equals 9. I don't want to crowd into the space for number 2, so I'm going to try to be careful with that. What would be smart here is when you see minus 2y, change that to plus negative 2y. It's the same thing, and then you won't be as likely to make mistakes with your signs. Now we know x equals 1. We found that a little bit ago. So I can put that in here. I can substitute it for the x. 1 plus negative 2y equals 9. All right, now I can subtract 1 from each side of my equation, and I get negative 2y. See how these canceled out here? Equals 8. 9 minus 1 is 8. And then my last step is just to divide by negative 2 here and here. And I get y equals 8 divided by negative 2 is negative 4. Okay, so I'm going to write my answer as an ordered pair. I put 1 first. I put negative 4 second in my ordered pair. That's my solution to this inequality. If you put 1 in for x, you put negative 4 in for y, you'll get a true statement in both of these equations. You could try, like 2 times negative 4 is negative 8. 1 minus negative 8 means 1 plus positive 8, which does equal 9. All right, and number 2, I was mentioning earlier that we would use substitution on this one, or I would suggest using substitution on this one. You can take 2x minus 1 here, substitute it in for y here, right here in this second equation. So my second equation, I have 2x minus 4 times y, but in place of the y, we'll replace it with 2x minus 1. And that equals 10. All right, now let's change this minus 4 to plus negative 4. And let's change the minus 1 here to plus negative 1. And then what I need to do is distribute the negative 4 through this quantity, or as I like to call it, we're going to bomb the fort. So I have 2x out front here, plus, and here we go, negative 4 times 2x is negative 8x, plus negative 4 times negative 1, that's positive 4. And this equals 10. So I don't have these parentheses anymore now that I'm done with the distributive property on that part right there. Now I can combine my x's because they are on the same side of the equation. And 2x plus negative 8x, it's really just 2 plus negative 8. You can add these coefficients. 2 plus negative 8 is negative 6. So I have negative 6x plus 4 equals 10. And then I subtract 4 here. I subtract 4 here. And I want to get rid of this plus 4 because then my variable term here will be isolated. It's by itself now. Negative 6x equals 6. Then we divide each side by negative 6. X equals negative 1. Okay? I'm starting to run a little low on space here, so let me bring this up on the screen here a little bit. Now that you know x equals negative 1, let's substitute that into the first equation up here. Put negative 1 in for x, and let's solve that, and then we'll know what y equals. So y equals 2 times x, which we now know is negative 1, minus 1. And it would be smart to change this to plus negative 1. All right, so y equals negative 2 plus negative 1. So then y then has to equal negative 3. Okay? Now that I know that, I have my x and my y values, I can write my solution as an ordered pair. Negative 1, negative 3. Put it in parentheses. That's our solution. We now know what our x and our y values are. Okay? So the first one, number 1, I liked using the elimination method. Number 2, I liked using the substitution method. Just so you know, on number 2, I could have used the elimination method also. Actually, it would be a pretty nice method to move. You know, my lights just turned off. Give me a second here. All right, those automatic lights You know, they shut off on us sometimes. All right, number 3, I have 8m plus n equals 3. I have 5m plus 2n equals negative 27. And so I'm looking at this and I'm thinking I want to use the elimination method. I like the bottom equation as written with the plus 2n. The top equation, I could get a negative 2n. That would go nicely with the plus 2n. If I multiplied everything in this top equation by negative 2. I don't have a lot of space over here on the left, so I'm just going to show it on the right here that I'm multiplying everything by negative 2 up there. Okay, so let's do that. Negative 2 times 8m is negative 16m. Plus negative 2 times 1n, there is a 1 here, is negative 2n. And that equals negative 2 times 3, which is negative 6. Okay? Now I'm going to rewrite this second equation underneath this. 5m plus 2n equals negative 27. And hopefully you're already a step ahead of me here on this one. If I go ahead and add these together, the n's are going to be eliminated because they're opposite each other. Negative 2n plus 2n is 0. It's just gone. So let's add these. Negative 16 plus 5 is negative 11m. And what does it equal? Negative 6 plus negative 27. We have to be so careful with our negative numbers. That's negative 33. Now I can divide by negative 11 here. Divide by negative 11 here. Zing. M equals negative divided by negative will be positive. And in this case, it's positive 3. 11 times 3 is 33. Now that I know what m is, I can substitute it in to either one of the equations. I like that top equation, 8m plus n equals 3. I'm going to write that down here, 8m plus n. Oh, that looks terrible. Let me try it again. 8m plus n equals 3. And that's before we multiplied everything by negative 2. I just want to use the cleanest version of that equation I have available to me. And now let's substitute this 3 in for the m here, because m equals 3. So I have 8 times 3 plus n equals 3. 8 times 3 is 24 plus n equals 3. And final step, if I subtract 24 from each side, we'll have to be careful here again with our negatives. We have n equals 3 minus 24. That's the same thing as 24 minus 3, everybody, except it'll be negative. And so we get negative 21. That's our n value. So m is 3. N is negative 21. When you see variables other than x and y, when you write them in an ordered pair, just go in alphabetical order. And you know what? M is before n in the alphabet. You can test these numbers up here and see if they work. 8 times 3 is 24. 24 plus n, which is negative 21. 24 plus negative 21 does equal 3. And if you try them in the second equation, 5 times 3 is 15. 2 times negative 21 is negative 42. 15 plus negative 42 does equal negative 27. You could check that on a calculator if you really wanted to, but it does work out nicely. All right, I don't have any time here to do a fourth example, so you're on your own at this point. You need to finish the worksheet, numbers 4 through 10, and it is due tomorrow. Okay, so good luck, everybody. I'll see you later.